So just to frame climate change, in a way, I'm hoping that you will agree with me. I know that there are probably people in this room that don't believe that climate change is a problem, or don't believe that there is such a thing as climate change, so what I want to do is try and frame it in such a way that we can find some common ground, things that we can agree with, so that the rest of my presentation makes sense. I think one thing that we can agree upon is that the Earth's climate is constantly changing, that it has changed over the last 100,000 years. 100,000 years ago, North America was covered with a giant ice sheet. That was it was one of the last ice ages that we had. In our history, we know from what the climate change scientists have discovered is that we've had at least 4 ice ages in the last 400,000 years. So the last ice age, the ice retreated, was about 10,000 years ago, and it was a result of the change in the composition of greenhouse gases in our atmosphere. There were volcanoes that had erupted and raised the level of carbon dioxide that caused the Earth's climate to warm up, and it caused the last big ice sheet that covered North America to retreat. It gave us the soils and the landscape that we have today. At that time, the Earth was actually only 2 degrees cooler than it is today. So in 100,000 years, the Earth warmed up just 2 degrees, and that caused the ice sheet to retreat. So it takes a very little, very small change in temperature to cause a big change on the Earth. Right now, we are on track. Climate change scientists think that we are on track for a 4-degree temperature change in the next 100 years. So if a 2-degree change can cause huge ice sheets to retreat across North America, you can imagine what a 4-degree change in 100 years is going to do. And that's why climate change scientists think that climate change is such a problem. Now we can argue over the reason why carbon dioxide levels are raising in our atmosphere. We can't argue over the fact that it's right now 400 parts per million, which is higher than it's ever been before. During the last ice age, when the ice retreated, there was only 300 parts per million carbon dioxide in our atmosphere. Climate change scientists think that the safe level is actually 350 parts per million. So we've already exceeded what we think is a safe level, but not by much. And that's why there's some hope that we can actually reverse climate change by bringing the carbon dioxide levels down just by 50 parts per million and preventing it from getting any higher than it is right now. So what does that have to do with farmers? The agricultural greenhouse gas emissions have been pegged at about 15%. And that, I've seen numbers as high as 30%, and it depends on what you're going to include in that number as the emitters on agricultural systems. If you're going to include things like transportation of your farm product to the market, that's going to raise that percentage. If you're going to count things like slash and burn agriculture and put in that number too, then it's going to be higher than 15%. That's when you're going to approach the 30% levels. But for our purposes here today, I'm going to stick with the 15% level. So most of these emissions on the farm are caused by 4 things. They're caused by chemical fertilizers. And the reason why chemical fertilizers are a problem is because the nitrogen component of chemical fertilizers require a lot of fossil fuels to make. It's another problem on farms is heavy machinery that run on fossil fuels like diesel fuel or gasoline. It's the highly concentrated industrial livestock operations that pump out methane waste on farms. I'm sure you've all heard of cattle belching and how big a problem it is. I don't think it's as big a problem if we farm right as they say it is, but I'll discuss that later in the presentation. Another source of carbon on our farms is the depletion of carbon actually in our agricultural soils, and I'll be talking about that a little bit more too. And that comes from Regeneration International, which is a website which deals with carbon dioxide and how agriculture can deal with those emissions. So if you want to find out more information on that, you can look on the Regeneration International website. There are also 4 carbon sinks on planet Earth. So these are places where you're going to find concentrations of carbon. The first is in our ocean. The oceans act as a carbon sink. So the carbon dioxide in our atmosphere gets absorbed by our oceans. In our oceans, it gets turned into carbonic acid. Have you ever heard of ocean acidification? It's called climate change's evil twin, because it is making our oceans more acidic. And when you make the oceans more acidic, it makes it difficult for ocean critters that have shells made out of calcium, because it dissolves those shells. It's also affecting little tiny organisms called plankton. They form the basis of the ocean food chain. So the plankton is eaten by things like krill, and then krill gets eaten by things like whale. So you're affecting that very basic rung on that ladder in the food chain, and that's causing a problem in our oceans. The other thing that plankton does is it actually takes carbon dioxide from the atmosphere. It uses sunlight. They live very close to the surface of the ocean, so they use sunlight to make oxygen, much like plants do, and they actually supply 50% of the oxygen that we need on Earth to breathe. So if we're going to wipe out our plankton, then it's going to cause a problem for us down the road. So that's why ocean acidification is called climate change's evil twin. The other place that you're going to find carbon on the Earth is in the soil. So right now, about 1,500 billion tons of carbon is found in organic matter that is in our soil. Another place you're going to find carbon is in the atmosphere. It holds 760 billion tons of carbon as carbon dioxide and the living components of Earth. And that includes you. You are a carbon sink. I am a carbon sink. Trees are carbon sinks. All the plants are carbon sinks. All the animals are carbon sinks. Some of us are just short-term carbon sinks, like us. There are some larger-term carbon sinks, like trees that can live 300 or 400 years old, to be 300 or 400 years old. So any living thing can be a carbon sink, but 2 of these carbon sinks are bad. Obviously, the ocean carbon is bad because the levels are getting too high, and our atmospheric carbon levels are too high too. So those are the bad ones, but the other 2 are okay. These are places that we can safely store carbon. And that's where agriculture comes into play, because we can take advantage of those safe carbon sinks. Okay, so as it stands right now, agriculture is a net carbon emitter. So the way we farm is releasing more carbon dioxide into the atmosphere than we are taking up. But we can change that if we farm differently, and I've listed 10 ways that we can farm differently and use up the carbon dioxide in their atmosphere. Okay, so how we can do it. Oh, there's only 9 ways, sorry. It used to be 10, I changed it. Okay, so first of all farmers using chemical fertilizers should be trained to use chemical fertilizers in conjunction with a carbon source or some kind of organic fertilizer. Ideally, we should stop using chemical fertilizers altogether. And the reason is because every time a plant uses 1 atom of nitrogen or one atom of nitrogen, it needs 4 atoms of carbon. But if you're a farmer that's using chemical fertilizers, you're only adding 3 elements to your soil, right? It's the nitrogen, the phosphorus, and the potassium. So you're not actually adding carbon to your soil. So the net effect of that after many years is that we've actually farmed the carbon out of our soil. We've mined it out, and now it's in our atmosphere. So if we increase the carbon content of our agricultural soils by just 1% a year, we would consume 12% of the annual carbon of our annual carbon emissions by 12%. just by growing food. And I'm not talking about the carbon emissions just from farmers. I'm talking about all carbon emissions. So we would make farming carbon neutral, plus we would be absorbing some of the emissions that are released by other industries into our atmosphere. And this is an important number because if we could stop the carbon emissions into our environment and then we farm better, we could actually take the carbon out of the atmosphere and we wouldn't be causing global warming and we wouldn't be causing ocean acidification. And if everybody did it, we could do it in less than 10 years. The other thing that we can do as farmers is build humus in our soils. Humus is a particularly stable form of carbon that can last hundreds of years in soil if it's not disturbed. Humus is made when a plant takes carbon dioxide out of the air, combines it with sunlight, and makes sugars. These sugars then they travel down the plant stem into the roots and they are released in the soils. In the soils, it attracts beneficial bacteria, which breaks down organic matter and releases nutrients to the plant. When you harvest, we usually take, well, a lot of times we just take the top of the plant. All that other stuff gets left in the soil. So if we don't disturb the soil after we harvest, we have all this, what they call liquid carbon, left in the soil in the form of humus. Humus that forms deep enough in the soil that it doesn't get affected by oxygen will stay there for a long time. So if we become good at building humus in our soils, we can take the carbon out of our atmosphere, we can start saving it in our soils, and we can keep it there for hundreds of years. One of the things that we could do to encourage farmers to be better, to become carbon farmers, is actually pay them carbon credits if they don't do things like till their soil and disturb that humus. So there's ways that we can encourage organic farmers and non-organic farmers both to preserve their land and make them as carbon sinks by encouraging our governments to pay carbon credits for us not to disturb it. Not only have we removed most of the carbon, 70% of the carbon is now gone from our soils through our agricultural techniques. And we've also killed off or eliminated 70% of the bacteria or the microbes in our soil that are used to break down organic matter and feed the plants. So the math, the part per million of carbon dioxide in the atmosphere, 1 part per million of carbon dioxide in the atmosphere contains 2.15 gigatons of carbon. If that is the case and we are at 400 parts per million, remember the safe level is 300 parts per million, we need to take 50 parts per million or 106 gigatons of carbon from our atmosphere and put it in the soil. That's not a lot, that's doable. The Food and Agriculture Organization, which is an organization that's part of the United Nations, says there are 8.3 billion acres of grass on the globe and 3.8 billion of acres of cropland. If everyone were willing to use carbon building practices on those acres annually, on average, an average of 2.6 tons per acre could restore 21 gigatons of carbon in croplands, and an average of 0.5 tons per acre could restore 2.1 gigatons. Sorry, that's on croplands. The original was on grasslands. So we could do it. This gives a total of 23.7 gigatons per year, and since we are interested in restoring 106 gigatons, that means we could do it in under 5 years. That's if we completely eliminated carbon emissions. We probably can't do that in the next 5 years, so they're saying we could probably do it in 10 years by just reducing carbon emissions. Because remember, we can actually take the emissions from other industries and put it in our soil. The other thing that we can do, and we can probably do this on our own farm, is make compost. Compost ties up carbon in organic matter, which we can put in our soil, and then that carbon is in the soil. As long as we don't destroy it, or disturb it and expose it to oxygen, that carbon stays in our soil. So what happens to organic matter now? It goes to a lot of our organic matter, our household waste, ends up in a landfill. In a landfill, it just rots, and it gets released into the atmosphere in the form of methane. That's right. And methane is also a greenhouse gas. It's a greenhouse gas, which is 10 times worse than carbon dioxide, but it also has a shorter lifespan in the atmosphere. It only lasts for 10 years. The problem with carbon dioxide is it lasts for 100 years. So if we stopped producing carbon dioxide this year, it would still take us 100 years to use it all up in our atmosphere. So methane is used up quicker, but carbon dioxide is considered worse because it lasts longer. Biochar, and this one is a little bit controversial because it actually needs a little more research, because one thing we know about biochar is if it's handled poorly, it creates a dust, which also acts as a greenhouse gas, because I think they call it black carbon dust in the atmosphere. It absorbs sunlight, so it still acts as a greenhouse gas. But if we handle it properly, biochar is another way that we can use up greenhouse gases from the atmosphere by storing it in the ground. It's actually taking our organic matter that we're right now sending to landfills and burning it in a low oxygen environment. In a low oxygen environment, it creates the organic matter is turned into a very stable compound that locks up carbon for 100 years if it's not disturbed. This is, I meant to add that the pictures in this presentation are actually from my farm and my greenhouse. So in my greenhouse, what I use is this is a pyrolyzed chicken manure. So this is chicken manure that has been burned, and it just looks like charcoal when you put it in the ground. And it's a very stable manure. It takes it a long time to break down, and it actually does more good the second year than it does the first year. But when we compost organic matter, we save 10% of the carbon in the organic matter and put it in the ground. But if we use the biochar, we can increase it up to 50%. So by using biochar instead of compost, we can increase the amount of carbon dioxide that we are putting in the soil. Obviously, one of the reasons why it's a little controversial is because it does require some energy to pyrolyze the organic matter. So depending on how you do it, you can have you don't necessarily get the same gain. But biochar can hold carbon dioxide in the ground for up to 1,000 years. So it would be a good carbon sink. One of the other things we can do is inoculate our soils with mycorrhizal fungi. Mycorrhizal fungi are found in the humus layer of healthy soils. And it's basically a network within the soil that you can't see it, but it connects plants together, and it can be miles long. So it's this huge underground network that transports nutrients from plants to plants and from other soil microbes like bacteria. It is through this process that liquid carbon is formed, or humus is formed. I talked a little bit about that on a previous slide. It also produces a substance called glomerulin, which is like a glue that holds little soil particles together. And that allows better water transport in your soils, and it allows air to get into your soils, and it helps the plant roots to grow, and you get a healthy plant above ground and a healthy plant below ground. What I do in my farm is I add alfalfa pellets to my soil, and you can see the mycorrhiza actually growing from the alfalfa pellets on top of the ground, and the alfalfa pellets are actually doing the same thing underground, so they're helping to build this healthy network that helps me get liquid carbon into my soil. And you can get it through compost, you can get it through compost teas. I get it through alfalfa pellets, and you can also get it through just adding humic acid to your soil. The next thing you do is you can go back to pasturing herbivores. Pasture-raised chicken, beef, and pork. Herbivores in the past have been given a really bad rap by environmentalists because they belch methane and they add it to the atmosphere. So they advocate eating less meat, so we need less herbivores, and that's your solution to climate change. But herbivores have actually been maintaining one of the most productive ecosystems to get carbon back in your soil, and that is grasslands. In a grassland, what you have is an extensive root system that is really good at creating humus in the soil. And what herbivores do is keep it at an optimum growing rate. So for any of you that grow grass, you know that there are different stages of growth in grass. And when it's little or tiny or just an inch high, it grows very slowly. And then it enters another stage where it grows very quickly until it reaches a maturity and goes to seed, and it stops growing at all. What herbivores do is they keep it in that quickly growing stage where it's most active and where you get the most photosynthesis and you get the most activity below ground as well. So herbivores have actually been keeping our soil ecosystems operating optimally for sequestering carbon. So if you're doing pasture-raised chicken or beef or pork, then you're actually sequestering carbon in your soil. You're not releasing it into the atmosphere, even if you're raising livestock. So I think livestock is not necessarily a problem as long as livestock farming is done right. Okay, the next thing we can do is globally end or limit the practice of unsustainable slash and burn agriculture. Are you familiar with slash and burn agriculture? This is where they go in to a forest, they cut down all the trees and they burn it, and then they use that soil to plant their crops in, because in some parts of the world that's the only kind of fertilizer they have. So it's kind of like creating a biochar, really, that I talked about in a previous slide. They're using those burned ashes as the fertilizer for their crops. The problem with slash and burn agriculture is that only works for a couple of years. So in a couple of years, they got to go and burn another section of forest and plant their crops. So this actually releases a huge amount of carbon dioxide into our atmosphere. Biodiversity is the key to being able to adapt to climate change. Biodiversity equals resilience. So it's really important to maintain our forested, diverse, biodiverse ecosystems as a strategy to mitigate climate change. We are the only creatures on the planet that have the capacity to protect other species. So we therefore have the responsibility of doing that. Okay. So the other thing we got to do is study this problem a little bit more. We got to ask our government to allocate some resources into studying the effects of things like pesticides and high nitrogen fertilizers on our soil ecosystem. It's one thing that most of the research that is done in Canada, I suspect it's the same in here in the United States, is actually sponsored by chemical companies that don't want to read bad outcomes, or if they get bad outcomes, the public doesn't get to read it. So it's very much controlled. So we need, even the university, research in universities is often sponsored by corporations who are trying to control the outcome of the research, or if they don't control the outcome of the research, they control who gets to see it. So we actually need to get our governments to do some more independent research into some of this stuff. If we can't identify what the problem is, how are we going to fix it? And the last thing that we can do as both consumers and farmers is to buy stuff from farmers that we know that are practicing regenerative agriculture. And they could be organic farmers or they can be conventional farmers, because there's good and bad in both categories. So we as consumers can go out there and help the farmers that are doing good actually succeed, whether we have governments helping us do that or not, whether the governments are helping the right kind of farmers or not. We as consumers can help the right kind of farmers. And farming is a profession of hope.